So we're fishing, and it says that the fishing is dependent on the weather, so it's kind of giving you already a hint. Tree diagrams work with independent and dependent as well. When it's independent, it doesn't change. Your probabilities do not change. When it's dependent, what happens before does change what comes after, because you gotta watch out for that. So the first thing, when we do our tree diagram, you have cloudy, right? It being cloudy or it not being cloudy. That should have been the first thing you started with. You could also call this would be sunny, right? Not cloudy, sunny, and this would be not sunny, right? Same thing, but I like to stick with the variables if at all possible. So it says that it's predicted to be cloudy 60% of the time. So we go 0.6 here, 0.4 there, okay? And then based on each one of them, we will consider the chances of hooking or not hooking a fish, right? So you should have hooking, not hooking, like whatever you go with, that should be all throughout this. This is like the first event, and then this is the second event. It's like answering multiple choice, right? The first question, second question, right? So if it's cloudy, what does it say here? I have to be careful. If it is cloudy, there's a 75% chance of hooking a fish. So if it's cloudy, if I go down this branch, then there's a 0.75 chance of hooking, and therefore I know it's 25% chance of not hooking a fish. Okay, so that's determined there. And I think this, if it's sunny, there's a 50% chance that he hooks. So this is sunny here. Okay, you're basically going down this branch. So I apologize. I know some of you that threw you off, but just know kind of how these work and then interpret, right? So then there's a 50% chance. So it's 50 and therefore 50. So that's what you should have there. Can I say something right here? The fact that whether you go up this branch or this branch, right? You're considering hooking or not hooking here, same here. The fact that these two numbers are different compared to these two tells you this is a dependent situation, right? That is absolutely critical. So the first branch will be probability of cloudy and hooking, probability of it being cloudy and not hooking, not cloudy and hooking, and this will be probability of not cloudy and not hooking. Okay, so there are your probabilities. Let me just, I don't have the answer right in front of me, so I'll have to actually compute this real quick here. 0.6 times 0.75, this is 0.45. And then 0.6 times 0.25, this is 0.15. This would be 0.2. This would be 0.2 as well. And let's see if this adds up. This is 60, 20, 20, that's 40. So this does add up to 1. So we're good to go, right? If you have this exactly the way this is, you get your 3 out of 3. Usually I make it worth 2 marks, but today I'm going to break it down for you. So I will say if this first thing is correct, you get a mark. If the second is correct, you get another mark, and then I'd give you another mark for having the ends correct. So let's say you messed up on this one at all. Then you go -1, and then I will still honor what you get here. Whatever you got, I will honor that. Okay, so if you messed up the very first thing, then it's -1. And if you messed up here, that's -2. I would still honor you multiplying everything out and writing out the probabilities at the end. Okay, so 1 out of 3. I would say if you did something, you get for sure 1 out of 3 today because we're still learning, all right? B. Oh man, I used up so much space. Anyways, what's the probability of hooking a fish? Probably that it's just asking this, probability of hooking. So you basically just go look for where that's happening. So that's 0.45 and 0.2. So that's 0.65. Okay, or 65%. I give you a mark for that. If I see you going back and adding up this one that has the hooking and this one, whatever you got there, you get the mark here. I call it step, right? Like the right step. Okay. So now this is the kicker. Let's see. This one is going to be the tougher one. And I don't have a lot of space, so I'm going to read. What is the probability that it was cloudy provided that a fish was hooked? Provided is the same thing as given that. Okay? So I'm going to just translate that real quick. Probably that it was cloudy given that a fish was hooked. Right? That is what they're asking for. That's what I would do first and foremost. Then you're going to grab your cheat sheet. Right? And on your cheat sheet, you should have this one. A and B is probability of A times probability of B given that this thing happened. Right? So this is going to be your pattern. It's like, okay, so if I have BA here, that means that it's the probability of A and B that we're trying to find. And this letter should show up here. Okay. But I write this down first, so I'm almost going backwards, filling this pattern in. So it's just to see the pattern, right? So I'm going to say probability of C given that it's hooked. So this is probability of C. Sorry. I just contradicted myself here, right? This is H, right? This goes in there. And this one, to be honest, the order doesn't really matter here. But I would go C and H. That's usually how it goes, but it doesn't matter. The and is important. It doesn't matter which goes first. So do I have this one, C and H? I do have that right up here, 0.45. Fill that in. Probability of hooking, if you already calculated it, it's right here. If you didn't, you'd have to add these two up, right? So that's 0.65, and this is just X. That's what we're trying to find. Divide by 6.5. X is equal to, I wish I'd be good at mental math, 0.6923. So 69.23%. And obviously this is going to be different if you had different numbers, right? So I'm looking for the work. That's why show your work. Don't just come up with a number, because if I can trace your work back to this diagram, you would still get the full mark here. Okay. I'm just going to say something here, maybe to give you hints. If C is ever worth 2 marks, if a question like C is 2 marks, it's most likely that they haven't made you do this yet. Like this is not gonna, so they will expect you to come up with the 65 here, right? pH is actually wherever hooking happens. Okay, that's the number that goes in there. So that's usually why it's 2 marks. So you gotta watch out. Yeah.
I didn't do it here, but I just wanted to make a test of it. Would you accept if it was done algebraically so that I do like C and H, or I do division instead of multiplication, and then I do that is equal to C?
I would say if you show me work and it adds up to what I get, sure, because there are multiple ways of doing this. I tend to stick to the formula, but all right. So what is this out of? 5, right? So I'm going to take this in real quick. That's it. Just put your name and last name. I'm just going to focus on this question there. And I'll record it. Give it back to you. Go to page 60. Do you remember this kind of stuff? Good old days? Some of you aced, you love this. You knew exactly what to do. I just want to review this because hint, hint, right? It doesn't go away. Same with equations, like none of the stuff really goes away. It says here, there's page 60, in a game, a piece is moved along the lines between A and B. The piece can only move down and right and must stay on the lines. If a random path between A and B is selected, this is new here. I'll show you how to do that. What's the probability that it passed through C? Okay, so what's the probability? Like, remember it was only number of paths? I'm going to focus on the path, and then I'll just do the probability next. Okay? So watch this. Can you, maybe, I just want you to ignore C right now. Just ignore C. How many ways from A to B? Figure that out. Do you remember how to do this? Do you have something on your study sheet that could help you here? So I'll give you a couple minutes to figure that out. You should be able to do this. So from A to B, how many ways? You can do the counting method inside, or you can do the formula, whatever you want to do. Let's see if you can do that. Okay, I'm not gonna tell you just yet. Now I want you to try. What if you had to go through C? Like, what if in this particular case we actually had to go through C? That's the only way to get to B. And so this is where you have to be careful. This is going to be A to C and, right, C to B. I'll give you a little hint here. What I usually do, I tend to do, I kind of say, okay, well, let's turn it into one of those questions where you don't really care about anything else. You just have, remember these questions where you had the and? I basically got rid of all the other boxes. So that's kind of what I want you to do here. Like, how many ways from A to B if you have to go through C? Try that now. Because these are the two things we need. Some of you was able to catch little things that you need to make sure you have on your study sheet. So it was good. So what's different between chapter 4, when we just found out the number of ways, and this one? It's the word probability, right? This isn't a very common question, but if it ever does happen, remember your numerator always has to be smaller than the denominator when you do probabilities. So basically, when you go from A to B, you consider this entire box, right? Entire, I'll write down entire box. Ignore C, right? That's important here in your notes, in my opinion. So you just count total number of blocks traveled divided by how many you travel horizontally and vertically. Okay, so that's what should go here. According to what I've seen, is it 462? I think it's safe to assume it's 462. So I'm just going to go ahead and trust you guys. You have to be careful how you enter this. Maybe I'll focus on that. I think most of you know what you're doing, but just make sure, right? 11 factorial, you get that. And then I would go 6 factorial times 5 factorial. If you remember 5 factorial, I think it's 120. Yeah, it is 120. So you go like this, and then you just go right top divided by bottom or something like that. But you have to be careful. Quite often, students get this right, but they don't get the right number. So you have to be very careful not typing it in all in one shot, okay? Next, A to C, C to B. So that's when you cancel out the boxes you don't want, because you have to go through this bottleneck here. And stands for multiplication. Or, the or is if you have 2 points that you can go through. Okay, then you're going to have to go A to that point, and then this point to that, or A to the other bottleneck, and then from there to there. So it's going to be a lot more work if it's an or scenario. A to C would be 6 factorial over 3 and 3. The pattern is that these two numbers better add up to the top, right? Like the 3 and 3 add up to 6. And then next is 5 factorial, and we have 3 factorial, 2 factorial, like that. Okay, what is this? 720 over 6 times 6, that's 36. This is 120 over 6 times 2, which is 12. This is 20, right? And this is 10. So that's 200 ways to travel that way. And this is where probability comes in. Probability would just be, well, it's the 200, like probability that you go through C is there are 200 ways that could happen over 462, which includes all possible ways to go to C, right? Not including, not all possible ways to go to B. So this is the probability there, which can obviously be reduced, but we'll just leave it at that because that would give you full marks already. I would just say know how to do number of ways. Sometimes it's probability, sometimes it's just the number of ways. So be careful, it's not always probability. Read careful on the test. Is it odds? Am I asking you for probability or I'm asking you for number of ways? Okay, I will ask you sometimes how many passwords can be made with these restrictions. It's not a probability, you just have to make sure you show me your counting method. Then I'll ask you what's the probability. Then you have to do a bit more work, right? So you got to watch out for that. So this one I wanted to review, make sure I'm looking here just randomly. Let me take you to a different question here that I thought was I wanted one where you grab stuff and don't put it back. Some of you were, oh yeah, here. Page 55, question 15. Page 55, question 15. Two cards are randomly selected from a pack of 40 cards. So I like that it's not always a standard deck, okay? It doesn't have to be. It could be marbles, it could be anything. Dependent doesn't have to be a deck of cards, okay? Numbered 1 to 40. The first card is drawn, then put back into the pack. The second card is drawn afterwards. What is the probability of drawing the first card with a number that is a multiple of 4 and a second card with a number that is odd? Show your work. Okay. How would the probability change if the first card is not put back? So we're comparing independent. This is card is put back. That's independent. And if it's not put back, we are turning this into a dependent situation. Dependent. Okay. I like the side-by-side component of this. I would like you to try that right now before I do this. Put your brain shift it into drive, right, and see if you can do this, and then I'll take over. Maybe split it in half. Do one on the left side, one on the right side, so you have enough space. If you're not sure, make a list of the numbers that would apply. Like if you're like multiple of 4, like how many cards are we talking about? Make a little list. It doesn't take very long. Then you know exactly what goes into that set, right? And then make a list with what is the other one? Odds. So that one should be easier. And then just be careful before you start on the test. Don't leave anything blank. Put something down. I'll try to fish for marks there. Okay. So for A, I'll do B on the other side. I'm just going to do multiples of 4, given that I'm only from 1 to 40, right? So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, right? Because 40 is included. And odd is half of the, right? Odd would be half of your deck. Odds be 20 cards. And so all you need to do here for A is probably the first card being a multiple of 4. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 40. So you want that and a second card that is odd. So you're grabbing a second card. The total does not change, right? You've got 20 cards that are odd. Okay. So you can probably cancel out, right? So 0 and 0 goes. That's 1 over 4. That's 2 over 4, which is 1/2. But you multiply that across. That's 2 and 16, which is 1 over 8. Okay, so that is your answer there. Because things are being returned. For B, things are not being replaced. So we're going to say we've got 10 out of 40 first. And guaranteed your second event, you'll have one card that is missing, right? So it should be 39. Now you have to ask yourself, is this event affecting the numerator? And in this case, it wouldn't, because all the multiples of 4s are even. They do not affect the number of odds. So you're still down to 20, right? These are even and these are odds. So they're not, you would also be able to say they're mutually exclusive, right? They don't share anything. So this could cancel 1 over 4. This one I can't. So this would be 20 over 4 times 39. Oh, my key doesn't have the actual, so it'll be 156. Phew. There you go. 20 over 156. Didn't ask for odds, did it? If it did, you know what to do, so read carefully there. Let's do one more with grouping, like in terms of grouping in an arrangement. I have to maybe clarify this. I will put a title to this one. Grouping, this is on page 52. Grouping within arrangement. We're not creating or selecting people to make a group, okay guys? We're just within that arrangement, within people like sitting in a row. It doesn't have to be in a row, guys. It could be rows of 4, but people can just move around every which way. It doesn't matter. Grouping within arrangement. This is the formula. G1 factorial. G2 factorial. So however, like the groups that are created, you would slap the number and then a factorial. Then you go total minus G1 minus G2 minus ... plus, oof, I'm going to run out of runway here. I'm just going to call it groups. But don't forget about the factorial at the end of that one. Okay? If you don't like this formula, I will show you, because usually the numbers are quite reasonable. But if not, then you'd be having to resort to this. So 7 friends, including Conrad, Craig, and Colin, attend a concert and buy 7 tickets in a row. Okay, so they're sitting beside each other. It's like pictures displayed. It's that kind of scenario. If the 7 sit randomly within the row, what is the probability that they will not be sitting together? You gotta be kidding me, they're not sitting together, right? But when you see a not, you know, when your parents say don't do this, you want to do it, right? So think of it that way. Like, let's figure out them sitting together. We'll subtract that from our total, okay? Do you want to try this first, or do you want me to just do it? Nike, just do it, okay? I'm going to give you this. 1, 2, 3, 4, 5, 6, 7. You grab, so 7 sitting in a row. Grab any 3 you want and circle them. or right, in this case it's 3. So this is the group these 3 friends want to sit together. So, but you can move them around. So that's where the 3 factorial, that would be like your G1. And then you have to think of 1, 2, 3, 4, 5. There are 5 ways that you can move everything else around, because this group can be moved to here, to here, to here, right? So that's where the 5 factorial comes in. So the way they can sit together, sitting together. Okay, so it took up a lot of space, but that would be them sitting together, those 3. So I just read carefully. It's not always going to be the not, but this is sitting together. So to find out the probability, when it's one of these questions, if there are no restrictions whatsoever as to where this sit, what would go down here? What's my universal? We ignore the 3 sitting together. It's just 7 factorial, right? The 7 friends, just mix them up every way you want. Okay. And then at the top, watch what I'm going to do here. I'm going to take that total and I'm going to subtract the number of ways where they would be sitting together. Okay, this is too much, and like usually on a test it's not that busy. Like I'll probably have asked you something before this, but we're just combining everything here. Now you're ready to go to figure this out. So 7 factorial, I always forget what that is. Is that 5040? Yes, it is 5040. And then we'll go 5040, which is all possible ways, subtract, this is 6 times 120, right? This should be 720, which is there. And then we'll just go 4320 over 5040. You can easily cancel the zeros. That'd be fairly simple. Does it ask for probability or odds? It does ask for probability. So we're good to go here. Okay. And if my answer is different than yours, like you just turn that into a decimal, turn yours into a decimal, compare them, or simplify, whatever. Okay. Is there a grouping, making groups here somewhere? I believe so. Yeah, 51. I'm going to go off script here. 51, question 4. I'm going to ask you to write me a question. So there are 3 or 4 marks in this test where I'm going to ask you to interpret what I did. Okay? So for example, if I gave you this, within this context, you're making committees of 5, and there are 10 women, 7 men. If I gave you this, could you write me a question that would require you to write this expression? You should be able to. You should be able to go back and be like, what's that 10 again? From 10, choose 3. Oh, 10 women, choose 3. From the 7 men, choose 2. Okay, so making, no, the probability. I should. If it had just been this, then it would be making groups of that. But the probability of creating committees containing 3 women and 2 men. Boom. So I'm gonna kind of test you like backwards. So there's 3 or 4 marks creeped in there, where one of them is even correcting like what was my mistake or what was the mistake that's in there. Sometimes those really show whether or not you understand what needs to happen. Okay, I'm gonna stop there.